If you've ever experimented in the kitchen, you've probably figured out that some things are easier to make than others. But no matter what you're concocting, you always start with the ingredients. You put them together according to a recipe, and the result is a delicious treat. Math functions are similar in this way. You start with one or more input numbers or values, which are the ingredients. Then you follow the function's rule or recipe. The result is an output number or value, your cooking creation. We can define math functions as relations, rules that relate elements of one set to elements of another. The set of inputs is the domain, and the set of outputs is the range. Suppose you're throwing a big dinner party, and you need to make sure you have enough forks for each guest. Since you're serving a salad course and an entree course, each guest will receive 2 forks. The number of forks is a function of the number of people eating, represented here as f of p equals 2 times p. In this function, p represents the number of people, and f of p becomes the total number of forks to be provided. The rule for this function is multiply the value of p, the input, by 2 to get the output value. Here's another way to visualize this function. The set of input numbers makes up the domain. The arrows show how each number or element in the domain is associated with a number or element in the range. In this graphic, the domain contains positive integers for p, 1, 2, 3, and so on. Inserting any of these values into the function results in an element in the range, 2, 4, 6, and so on. The arrows are used to show how an element of the domain is associated with or mapped onto an element of the range. A crucial point to remember. For a relation to be a function, each element of the domain must map to exactly one element of the range. Let's explore functions further by trying some samples. Running is a popular way to exercise. You can use this formula to determine the calories burned during your run. F of t equals 0.0021 times t times w times s squared. Here, t equals time in minutes, w equals the weight of the runner in pounds, and s equals the speed of the runner in miles per hour. Suppose this runner weighs 200 pounds and runs at constant speed of 5 miles per hour. We can substitute these values for w and s and compute to get this linear function, relating time running to calories burned. For this runner, the function is f of t equals 10.5 times t. A function is a relation that maps each element of the domain onto one element of the range. The elements of the domain are all the allowable inputs of the function, and the range is a collection of all the outputs that would come from the entire set of possible inputs. In this calorie function, the domain is the entire set of possible running times. Another way to show the domain and range is by making a graph of the function. Here, each point on the graph represents one pair of input-output values. For example, the point 20, 210 shows that if the runner is out for a 20-minute jaunt, he'll burn 210 calories. For a relation to be a function, each input value must yield one and only one output value. In this calorie relation, using a value of 20 for t gives us only one answer for f of t, 210. So far, so good. But what about every other input value? You can determine if your graph represents a function by performing the vertical line test. Draw vertical lines that intersect the graph parallel to the y-axis. If the graph represents a function, then every vertical line will intersect the graph no more than once. Here we can see that the calorie relationship passes the test. This is true for any linear relation that can be expressed in the form y equals mx plus b. The vertical line test is a graphical way to determine whether any value of x relates to only one value for y. Take a look at the direction of the line. Notice that the longer you run, the more calories you burn. This can come in handy if you want to burn off meals, not to mention the general health benefits.